Well, it probably started in fifth grade when we were taken in to watch a movie called Hemo the Magnificent.
Okay.
And I was fascinated by the fact that I could feel my heart in my wrist, it was about circulation. So that was the first thing. The next thing, as I was pushed into science forcibly by the fact that Sputnik beat the Americans into space and was flying a satellite over American territory, and there was nothing America could do about it.
Mm-hmm.
So they realized they were behind and they pushed all the schools to push science. And that culminated with me getting a free semester or 2 semesters of college to go to med tech school. Plus, I was
Okay.
paid a stipend for keeping my grades above I think it was a C plus. It might have been a B plus. I
Hmm.
can't remember. It's been a long time.
And so, but why medical laboratory science specifically instead of any other scientific field?
Well, I chose that because I wasn't smart enough to be a doctor. So that it boils down to that.
Oh, you also need to be smart to be a
And
scientist,
this
though.
laboratory was a good field.
While you were studying, was there any particular specialization that caught your attention? Was there anything specific you wanted to get into?
Well, in 1969, we were still mostly a test tube science. So, what you experience in college laboratory doing experiments was basically what we did.
Mm-hmm.
And one of the things, the hematology impressed me because to do the lupus test, which would be for the anti-nuclear antibody, they would draw us students and give us $2 to harvest our white cells to mix with a suspected lupus patient's plasma for 4 hours. And that damaged our white cells and made lupus cells that we would identify under the microscope.
Mm-hmm.
So you can Google lupus, an LE cell, and probably take a look at the blodge we were looking for in the cell.
Mm-hmm.
Anyway, that impressed me. That was almost like feeling my pulse in my wrist back in fifth grade. Here we were using my cells to identify a lupus patient.
Yeah.
And it wasn't just my cells. We usually drew 2 or 3 lab techs
Yeah.
and had a mix of white cells.
Mm-hmm.
So, and then the other field I liked was microbiology, but I never actually worked that field because you had to pretty much work days to work microbiology and they paid less. But I
And
never, well, when you work an evening shift, you do gram stains on spinal fluid and you set up gonorrhea cultures and CSF cultures, but that's the limited scope of microbiology when you work
yeah.
evenings and
Mm-hmm.
night shifts.
Yeah.
You don't
And
do much in micro.
and what was safety like back then in the lab? Was there a big difference between what was happening before and the way it is now, as far as microbiology?
Oh, yes. As a matter of fact, that was one of the things that I was going to talk about being a big paradigm shift is in microbiology. We started with a media maker making test tubes of different uh, chemicals to see if the bacteria would grow on them. And later on, the API strips replaced all of that and
Hmm.
eliminated a job of media maker in the laboratory. So that was one of the things that really changed microbiology.
Yeah.
And now currently there's even another paradigm shift in that you're identifying cells in the ER with monoclonal antibodies to certain pieces of RNA and DNA
Yeah.
of the bacteria.
Hmm.
So the culture never even gets to the laboratory. They
Yeah.
identify it right in the ER.
Yeah, it's a lot faster now. Doctors already with a little bit of training are able to do their own testing. But I guess now it's causing some issues because some are scared that medical laboratory scientist jobs or technician jobs eventually might disappear. Do you think that's a possibility, or do we always have to count in some sort of human elements for testing to actually be done the way to a certain level of excellence?
Well, I just like I had to be adaptable in 1 year's time, I had to adapt from test tubes to automation. We got automation the very next year after I graduated. Uh, you are going to have to be just remain adaptable because technology is not going to stop. There's always
Yeah.
going to be something newer and better in the future, and you're going to have to adapt to it.
What I tend to find interesting when I have these discussions is uh, the difference between. So when you're talking about the fact that back then you were still working with test tubes and all that, actually, we're now getting at the point. I mean, here where I am in Benin and in lots of African countries, actually, we're actually getting at the point where it's now that we're making the switch from the test tubes to actual automation. Although in some cases, we're sort of skipping one step and we're going directly from the test tube stage to the much more rapid test you're talking about. So it's kind of interesting to always get that little difference because here, for example, in some rural areas, in some semi-urban areas, and sometimes even in some urban areas, you're still going to see very manual tests being done. Whether it's biochemistry or it's microbiology, we still prepare culture media. And so that's one difference, I think, between the way things are over there and the way things are here.
That's
But
another thing. You mentioned biochemistry. That's another thing that changed a lot due to Henrietta Lacks, who was a cervical cancer patient in the 50s. Everybody learned genetics off of her HeLa cells, which are still
mhm,
being used in colleges today. So a part of Henrietta Lacks is still living
yeah,
in laboratories through her cancer cells.
yeah,
Uh, and from Henrietta Lacks, we went to taking myeloma cells, which produce gamma proteins, and teasing them to make antibodies, which eliminated most of biochemistry down to antibody antigen reactions, which fluoresce or something, and you measure them, as
mhm,
opposed to it being an all-day process, maybe of boiling down urines or concentrating it in some way or electrophoresis. So a lot of uh, that was really tenuous work, tedious
yeah,
work,
yeah, it
in
was.
originally ended up being a very short test that was cheap enough that everybody could order it. So
Hmm.
that's where you
Yeah,
are today, is
yeah.
a broad spectrum of tests that a doctor can order because they're cheap enough to do.
Hmm. Yeah, one thing we can certainly say is one thing technology has done is it's made things a lot cheaper. And at the same time, it's also made things a lot faster. You can go through a lot more samples much faster than you could in the past.
Uh, Automation played a big role in what we are doing today versus what when it was all manual. When I started, we were writing things on paper chits and delivering them to the floors to be inserted in a paper medical record.
Yeah.
So automation took that part away. Instant, as soon as you verify your results, they're available to the doctor. Automation took away having to know critical ranges on tests and having to call the critical ranges from your head. Now the computer tells you when you have a critical and you need to do something with it. And in blood bank, automation pulls up records rather than looking through a card catalog to find see if a patient's name is there. So obviously that also reduced a lot of techs.
Yeah.
Because if you think about that, the expertise of the tech is less because the computer is doing more.
Yeah, but still, the computer is doing a lot more. It's helping, but I'm sure there are some skills you've seen over the years that you believe are timeless. Some things that any laboratory technician, any laboratory scientist needs to have. What are those according to you?
Well, in my day, it was knowing whether you were using a 2-deliver pipette or a 2-contain pipette or measurement. All that measurement stuff and pipettes, most of that is gone. Everything is purchased these days. You know, there's very little that you have to make up unless it has to be a fresh reagent.
Yeah.
By the way, I'm the last person that knows what a direct and indirect bilirubin is because I actually did the test in a test tube for direct bilirubin and indirect bilirubin.
Yeah.
So
Yeah, I mean,
those days are gone. They've got new things that can be put on a machine to give you a
yeah.
direct and indirect bilirubin these days. But
Well, if it makes you feel better, I actually do the direct bilirubin and indirect bilirubin in a test tube for the most part. So one of the reasons too why I wanted to discuss with you was a post you made in the Medical Laboratory Science Hidden Heroes group, where you were talking about the 3 big things that changed laboratory work for you. And if I remember correctly, you've already addressed 2 of those, the Henrietta Lacks cells and the way they affected how testing is done in the laboratory. And then you also talked about the Cold War and how that also affected the emphasis that the American government put on science. What else was there?
well, the 3 main things that have changed for me have been, I've already mentioned monoclonal antibodies. I've mentioned AI taking over a lot of the lab work. The only thing and I mentioned APIs in microbiology. The only other thing that I can think of is not necessarily, well, I guess it does apply to a lot of fields. That was the shift in the belief that the uterus and the placenta is a blockade between a growing baby and the mother, and they had to change that idea. So that's another paradigm shift to the mother and baby exchange cells all through the 9 months of pregnancy. And what that eliminated in biochemistry was we used to do amniotic fluid taps on babies. Well, not babies, but the fluid, and measure the lecithin sphingomyelin ratio, the LS ratio, to determine whether they could be taken and have usable lungs. And if the LS ratio was right, they could go ahead and do the C-section that day. And if it wasn't right, they would have to wait another week or two. That all went away when they found out that baby cells could be found in the mother's blood. So there's very few amniotic fluid taps anymore. And it's all done on mother's blood now. They harvest the baby cells in the mother's blood and do the same tests that used to have to be done on amniotic fluid. So
yeah, which makes things a bit easier for the baby, I guess, and for the mother too.
That's the big changes that I can think of between where I started and where you're at now.
Now, moving a bit away from the more technical aspects, some people find it hard to manage work and life.
On managing your work,
Yeah.
The biggest thing I learned, because I worked the night shift and the evening shift, was getting on a 7 on, 7 on, off 12-hour cycle.
Wow.
That spares your circadian rhythm. It spares you having a family life, at least for 7 days.
Yeah.
I found that was the least stressful. The worst times was when I was working 2 jobs, and sometimes I didn't get to sleep for quite a while because I was working different shifts at different hospitals. So that was dicey. And I'm glad I didn't do that for very long.
Yeah. Was it usual for
That's the
people
only
to...
suggestion I have, is be adaptable. And if you have to work evenings or nights, well, not evenings so much, but the night shift, work 12-hour shifts.
Yeah. For me, I think that would be a lot. I'm not sure I'd be able to do that. But I guess it also depends on everyone. We get used to different things. But one thing I wanted to ask is, was it common for people to have more than one job as medtechs back then? Because I believe we've had a couple interviews. I believe you're the second person telling me that in the same period of time they used to have 2 jobs. Was it a common thing?
I've had as many as 3 jobs. I was in the reserves in a laboratory section, which only met 1 weekend a month. So, I mean, that wasn't a bad gig for the 3rd job.
Oh, luckily it was manageable. All right, so one last thing. The way I usually end is to ask, what's the hardest thing you've had to do but are the most proud of in the lab?
What's the hardest thing I've done?
Yeah, hardest thing you've had to do in the laboratory.
Is that what you said?
Yeah, hardest thing you've had to do but are also the most proud of.
Well, I'll reminisce a little bit here. The Coulter counter was the only blood cell counter for a long time in the laboratory. So in hematology, it was Coulter, Coulter, Coulter. Beckman bought out Coulter and kind of rested on Coulter's fame. This is like 30 years later. And I had to write an opinion between Sysmex, the new kid on the block, and Coulter, which were the 2 we had boiled down to reinstalling aged equipment. And I went against Coulter. It was like divorcing. It was like separating from your baby. Someone that you had worked 30 years with, and Sysmex offered more. And I equated it to the commercials of the time between Avis car rental and Hertz car rental, which was number 1. And the commercial said, when you're number 2, you try harder. And I equated that in my comparison that Sysmex was a new kid on the block and they were trying harder. And so they dropped Coulter and went with Sysmex. And so I always remember that because I was pretty tough on Coulter. They were the leader for so long, and everybody was wedded to Coulter, but this new kid on the block came around, and
Yeah.
so I always remember that.
And finally, do you have some last words for anyone who's trying to get into the field, who's unsure? What do you believe? What could you say to encourage them to get into this field?
Well, I think it's more of a sausage factory now. You're doing a whole lot more work depending on automation. And when the automation fails, it can be disastrous because you got another 50 or 75 specimens that you've got to get through the night.
Mm-hmm.
So in that respect, it's more of a sausage factory. And the only thing getting into the field, it's tough if you have to borrow a lot of money to go to college to get in the field. Your return on investment may take a while to pay off.
Yeah, it's true.
But I think that's true everywhere. If you're going to be a history teacher, you're going to be in debt for oodles of time too.
Yeah. So I guess the most important thing is essentially get into a field that you love, if it's going to involve college studies.
Well, I appreciate you interviewing me, and I hope I didn't. I'm a geezer, so if I stretched out a story, that's what geezers do, and I apologize. But
It's fine. Thanks a
I
lot for
think some
accepting to
people
be
might
here.
find it interesting anyway,
Yeah,
or
I'm sure.
helpful.
Yeah, sure will. So, Lab Experts, thanks a lot for being here with us today. I hope you've been able to learn something from this interview. If you have any questions, put them in the comment section. We'll try to answer them as soon as we can. And also, if you liked this video, if you learned anything from this video, make sure to share with others who might also learn from it. Thank you, and see you next time.